6800 microprocessor pocket trainer. In this project, we explore building a trainer for the Motorola 6800 microprocessor. The system uses no 6800 hardware. Instead, the CPU, ROM, and RAM are simulated using a Raspberry Pi Pico. The second core handles I/O for keypad entry and a 7-segment character map that is placed on an OLED 128 by 32 I2C display. This I/O is mapped to RAM addresses. Although obsolete, the Motorola 6800 microprocessor is simple, with only a few registers. This makes it ideal for learning about assembly coding. A few assembly language examples are covered. However, the focus is an overview of the trainer showing how to build and use it. The 6800 processor, 8-bit registers, accumulators A, accumulator B, condition codes, 16-bit registers, program counter, index register, stack pointer, I/O, RAM, ROM, memory mapped to 64K by 8 bits. If you're interested in building and programming the trainer, here are some resources. The one at the top contains everything needed to build the project. The trainer can operate in the keypad entry mode or via the USB or serial UART interface. A slide switch allows reset booting to either mode. The trainer mode is standalone using keypad entry data and a simulated 7-segment display for output. Booting to the trainer mode brings you to the command input mode. Commands start with a single key press, followed by hex data, address data, or a key press to return to command mode. Note, although this trainer operates like the Heathkit ET3400, the supplied monitor program is not compatible. The M6800 emulator implements added opcodes. It uses a different process to call and perform keypad functions. However, the hardware appears at the proper memory locations. Project information and source code may be found at https://github.com/simple-circuit/6800-trainer. In addition to this small pocket 100mm by 70mm version, plans are available for a larger 120mm by a 180mm board with a 7-segment LED display and 12 by 12mm keys. Here is what you need. A schematic diagram for the trainer. Install and solder the 18 push-button switches. This is an array of 16 hex keys and 2 extra keys. One is used to exit the auto data entry mode. Next, install the 2 reset button switches and the 2 mode slide switches. The 1K pull-up resistor is used on the Pico reset line. The 10K pull-up is optional. Pull-up resistors are present on the display module. Cut the 40-pin sockets to make the following strips: 2 20-pin, 2 3-pin, 1 4-pin, 1 6-pin, and 1 7-pin. Install and solder the socket strips. Cut the male header strip into two 20-pin sets. Install them into the 20-pin sockets. Install the 4-pin male header into the 4-pin female socket. Place the Pico on the header strip. Note the orientation, then solder it to the pins. Place the display on the 4-pin header and solder it. Place the trace slide switch in the down-off position. Place the trainer UART switch in the trainer up position. Connect a USB cable between the Pico and your computer while holding the white Boot Select button down. Release the button. Drag the SIM 680B trainer I2C S.UF2 file into the Pico boot folder. The 4-pin OLED display has no reset line. It may occasionally fail to reset. Remove, then plug in the USB cable to reset the display. The mini label PDF file contains print strips that can be cut into key labels. Use double-sided sticky tape to attach. Fit them above the key row you are marking. The trainer has 3 example programs in ROM memory. There is a program located at address F800 that will move the programs to RAM memory. Press the D-Do key, then press F800. The program will prompt you for a key press. Press key 1 to load the message program. To run it, press D, Do, then 0000. The trainer starts execution at address 0. The display simulates an 8-character, 7-segment display. To display in a standard font, press E, Examine, then C109. Press C, Change, then 01. This loads 01 into memory, C109, turning off the 7-segment line and enabling the text line. To clear the old display line, press F, Forward, then C, Change, and 1, 1. Now press D, Do, 0000 to run the program with a text display. Program 2 reads ADC channel A1 and converts the 10-bit binary value to the decimal voltage. Connect the end termination of a 1K potentiometer to ground. Next, the wiper connects to A1. Last, connect the other end termination to positive 3.3 volts. Do not connect to 5 volts as it will damage the input. Do F800 and select App2. Do 0200 to run the program. Move the potentiometer to vary the voltage. The display shows the voltage, which lies between 0 and 3.3 volts. Press 6800 Reset button to exit the voltmeter. Do F800 and select 3. Connect a wire to the 60 Hz output pin. Do 0200, then connect the other end of the wire to the NMI pin. This generates a non-maskable interrupt every 16.67 milliseconds. It will be used to time a 5-minute chess clock. Press the 0 key to start player 2's clock. When player 2 completes the move, pressing any key other than 0 starts player 1's clock. The player's flag is fallen when the clock reads 0. Press the 6800 reset button. The trainer returns to command mode, but then the clock appears. This is because the interrupt routine is still running. Remove the jumper wire to stop interrupts. In Windows, start simple CRT.exe and select your serial port. Then click Open. The red box should turn from red to green. Slide the switch to UART and press 6800 Reset. Reset and FB93 are displayed. The hex value is the vector address for Serial Monitor Program. Type L at the prompt. Click Send, then File. Select the star.s19 file type and locate the app9.s19 file. Open it. This sends a Motorola S record file containing an assembly program. Move the side switch to Trainer and press the 6800 Reset button. Note the vector address is FC00, which is the Trainer Monitor Program. Press Do, then 0000 to run the program. It displays the binary values for the bits in the I/O located at hex address F011. Starting from the left to right, bit 7 is input A2. Bit 6 is input A1. Bit 5 is LED 0 is off. 1 is on. Bit 4 is V-bus power. Should be 1. Bit 3 is PS mode. Should be 0. Bit 2 is D2 in. Bit 1 is a 60 Hz clock. Bit 0 is trainer UART slide switch. 0 is trainer. 1 is UART. You can use as a general purpose input in UART position. Sliding the trainer UART switch will change bit B0. Bit B1 will toggle between 0 and 1 as the 60 Hz clock changes. You can pull this input for timing. Connect a wire to D2 in and touch it to ground. This changes bit B2. Analog inputs A1 and A2 are associated with bits B6 and B7. They work like general-purpose digital inputs, but they are not pulled high, they just float. Note: only apply 0 to 3.3 volts to the inputs. The purpose of this video is to introduce the hardware that can simulate a 6800-based system. For those not familiar with coding a 6800 processor, you can start with a few immediate operand instructions. Immediate instructions operate on the memory byte following the single byte instruction. A few accumulator instructions are inherent, as they need no additional memory input. This is because only the accumulator and condition codes are affected. This is an example of load accumulator A, immediate instruction with the program terminating in a branch, always to self. With the trainer showing ready, press the A auto insert key. Enter address 0000. The trainer waits for data entry starting at address 0000 hex. Enter the following bytes: 86, 4B, 20, and FE. Press the red button twice to exit back to ready. Press 3 to examine the program counter. It should be set to 0000. If not, use C, change, and set it to 0. Press 0 to return to ready. Press 8 to single step the program. The opcode at address 0000 is executed. Then the trainer returns, showing the next in-line opcode. It is at address 0002, and the 20 opcode is a branch always. The FE operand at address 0003 is the value -2. When the branch always instruction completes, the program counter is at address 0004. The instruction subtracts -2 from the program counter, and execution resumes at address 0002. Press 8 a couple more times, and the single step always returns to address 0002. Press 0 to return to the ready prompt. Pressing 1 shows that 4B was loaded into accumulator A. Press D for do and enter the start address 0000. The display shows user to indicate the programming is running from the user's stack. It will endlessly loop to address 0002. Press the 6800 reset button to get the ready prompt. Pressing 1 shows accumulator A has 00, not the 4B value loaded by the program. After pressing the 6800 reset button, the trainer program clears registers and assigns default values to the stack pointers. The single-step operation runs one instruction opcode, and all registers are saved on the stack for display and use for the next single step. Since the program counter was reset to 0, pressing the 8 key will single-step through the load instruction. Press 0 to get to the prompt, then press 1 to examine accumulator A. When assembling programs by hand, looking up values, a coding sheet helps to organize the process. A coding sheet and example filled sheet are provided to help you write down your programs. Micro coding sheet. Sample load accumulator A. Memory maps. RAM area memory mapped peripherals handled by Core 2. ROM memory mapped areas handled by 6800 Simulator Core 1.